So another way that we can possibly have to improve the classifier is a radial basis function layer. So a radial basis function, the idea is that we have this convolutional neural network that produces 128 vector of 128 dimension for each one of the prototypes. Now, when we have a prototype of 128 dimension, in a subsequent view of the network at each location, we receive another 128 prototype number. Instead of just matching the distance with that prototype, as I showed you at the beginning with the original online learner, the idea is to add something a little bit more complicated by just for every prototype that we have, had radial basis function, which is just a Gaussian spread basically around the prototype that we save. So we had this radial basis function classifier to the convolutional neural network. And this is good because the convolutional neural network is not really possible to train it in real time with just these few samples that we get from one or a few prototypes. So instead, we train the RBF again. And training is basically changing the number of neurons by growing or pruning. So every time you see a new prototype, for example, that is very different or it wasn't included in the previous prototype, you can add another prototype of that specific object and keep adding them and pruning them for removing them after a while if they haven't been used. So one has to decide the growing pruning criteria. The RBF layer basically has only one parameter, the spread of the Gaussian for each one of these prototype. So it's a fairly simple classifier that one can use. One can use only, we decided to use only positive prototypes as opposed to positive and negative. For example, you can have examples here of the object and example of the background as well and create a classifier like this. So we decided that we didn't want to have negative prototype. The convolutional neural network should be able to do this, as inspired by our vision, should be able to differentiate between the object and the background. So we only included positive prototypes. So here we only have different views of the same object. The idea is that you add one prototype for every new view of the object. Now, if the number of view becomes really high, then you have a growing computation because this last layer basically becomes bigger and bigger as you add prototypes. So that might slow you down your performance if you have too many objects and too many prototypes. So you really have to prune them. So if you haven't seen a prototype for a while, so for example, if the face is to the side and it's been to the side for like many frames, then you might want to eliminate the front face and maybe you should be able to recreate it again later. So the idea is really to track the last seen object, basically, or the last few seen objects and not the very far past. So unfortunately, adding an RBF didn't really improve our system in the TLD dataset. It didn't improve because we found out that, again, the classifier and convolutional neural network or deep network is really the limiting factor here. Well, this basically brought us to the end. The only other options that we have was to improve the convolutional neural network COMNET classifier. We still really don't know how to do this. It's a tough problem that the lab is working on and a lot of other people are working on. I wanted to give you a couple of conclusions about this presentation on online learner. So first of all, this is a very interesting problem, the online learner, because you really need to perform one-shot learning. So you need a complicated system that can track and detect, has a lot of parameters really, and it has to be general purpose. Yet you have so few training examples. So you really have, this is really a great example of what needs to be done by unsupervised learning. You really need to train something as supervised or maybe supervised, but it has to be general enough. Currently, I prefer the view that such a system should be trained and supervised as much as possible to extract the best features that can be done for recognition, tracking, and segmenting the object at the same time. Also, the detection of the object. We had a lot of problem, for example, setting up the threshold of detection that decides whether an object is on the frame or not. So we need a classifier that can do all these things. But also it cannot be a huge beast. It has to be something lean and fast so that it can be used in real-time application. So I think this is really a great problem for deep network, how to do this. And I would move away from doing work on a single data set, doing deep network, and try to think about how you actually can use your deep network to track an object in a scene while it's moving and changing appearance.